Good afternoon. We are going to be continuing working in section 7.7 today. Take a few minutes and read this, the first three paragraphs again here and refresh your memory on what we did here, how we figured out the slices of the 9-inch and the 8-inch round and the slices of the out of the square and the rectangle. This was the picture that we did. Remember all of these areas. And then come down here, and right before the end of the hour, let's see, it was Friday when we did this, we changed this number down here to be 5 degrees instead of 4 degrees. We changed it to a 5-degree error. Please pause the video and refresh your memory on what we did. Seriously, pause the video, refresh your memory on what we did. I mean it. Pause the video and refresh your memory on what we did. Okay, welcome back. Thank you for taking my advice and my direction and pausing the video to remember what we did last week. We are working now on page 41. Page 41, starting right here at number 2, using this criteria, what's the smallest and largest amount of pie that you might get in a slice of pie taken from an 8-inch pan? Okay, using this criteria, what criteria are they talking about? They're talking about this criteria that one of the students is to reject any slices of pie that are more or less than 5 degrees off of that exact angle measurement. So, for the 8-inch pie, we said that we want 72-degree slices, but with that error of plus or minus 5 degrees, or I should say with an allowable of plus or minus 5 degrees, the slices will vary between, all right, so 72 minus 5, 67 degrees, and 72 plus 5, 77 degrees. So again, I did 72 minus the 5, and 72 plus the 5. So now, what's the smallest and largest amount of pie that you might get in a slice? So, amount of pie, then we're talking area. So we're going to have to find the area, and these two are going to use the area of a sector. And you recall that formula, degrees over 360 times pi radius squared. This is the fraction of the whole circle. So for the 67 degrees, 67 over 360 times pi times radius. For the 8-inch pan, a radius was 4 squared up to, all right, now we're going to put in the 77, so that would be 77 over 360 times pi times 4 squared. And we're going to talk about how to do this in your calculator with limited retyping of everything. So if you have the fraction in your calculator, use the fraction bar. And that's 67 over 360 times pi times 4 squared. Okay, 9.355. This is 9.355 inches squared. All right, now to do the 77, don't retype everything. Just arrow back up and grab that equation again, or that expression, and then use the left arrow and all the way back through, and just take out that 6 in the 67 and change it to a 7 for a 77. Much easier than having to retype everything. And that's 10.751 inches squared. So, smallest right here, Largest right there. All right. Now, same idea this time, but in the 9-inch pan. So using this criteria, that criteria is that plus or minus 5 degrees. This criteria, that's that plus or minus 5 degrees. What's the smallest and largest amount of pie you can get in a slice of pie taken from a 9-inch pan? So from the 9-inch pan, oh gosh, what were the slices in the 9-inch pan? Go back and look them up. In the 9-inch pan, the slices were 60 degrees, yes. 60 degrees plus or minus 5 degrees. So that means your slices are going to go from 60 minus 5, so 55 degrees, up to 60 plus 5, 65 degrees. And then we'll just set up that area of each slice. The degrees out of 360 times pi times, okay, the radius this time, not 4, 4.5 squared. And then this one, the area would be 65 over 360, pi times 4.5 squared. Again, I'm going back into my calculator, but I'm not going to retype everything. I'm just going to arrow back up and grab that line. I'm going to change this to be a 4.5 squared. And then I'm going to go back up into the angle, and instead of 77, I want 55. And then before I even write that number down, I'm going to go back up and change the 55 to a 65. Okay, now I can write my numbers down. And we have 9.719 and 11.486 inches squared. So there's your smallest. And here's the largest size out of that 9-inch pan. Okay, now, the student in charge of quality control finds it rather difficult to measure the angle of the pie because he's putting a protractor on top of the pie, something like this, although this is a full protractor, but you don't want something like this set on top of your piece of pie that you're going to eat. So he says that he suggests they cut a piece of string that could be used to measure the outer edge of the pie to let servers know where to make the next cut. So instead of sticking a protractor on top of this pie and trying to measure that degrees here, he's going to take a piece of string, and figure out how long should that string be. Can you see the string on there? There's a piece of string. How long should this string be so that the pie, the slice of pie, is the appropriate size or appropriate angle for that sector? All right, so here we go. Oh gosh, if we're going this outer edge, we're not doing area anymore. We're doing arc length. Arc length is the length of that edge along that outer circle here. And arc length, you recall that formula, degrees out of 360 times 2 pi r. All right, how long should this string be to measure the arc of a slice of pie for the 8-inch round pies? 8-inch round, okay, degrees. Degrees in the 8-inch round was 72. So 72 over 360 times 2 pi times that radius, 4. Now, 72 over 360, you can simplify that fraction, or you can remember it's the 8-inch round. There were 5 slices, so that slice is 1/5. So this is 1/5 times, and 2 pi times 4 is 8 pi, which is 8 pi over 5. And when you zap that in your calculator, now in this case I opted not to use the fraction bar. You can if you want to. You will get the same answer, so that string has a length of 5.027 inches. Okay. How long should that string be for the arc on a slice of pie? For a 9-inch round pie. 9-inch round pie, degrees, 60 over 360 times 2 pi times that radius, 4.5. 60 over 360, 1/6 times 2 times 4.5 is 9 pi. This is 9 pi over 6, which simplifies by 3 to be 3 pi over 2. And if I type that in, we get 4.712 inches. Notice it's not inches squared now, it's just plain old inches because we're doing a length as opposed to an area. Hopefully you're plugging in the calculator along with me on this one, or you're pausing to make sure that you can get the same numbers that I get off of my calculator. I know it's button pushing, but you do need to practice. All right, now let's talk about Wendell. Wendell really likes pie, and he has offered to pay double the price for a slice of pie that is guaranteed to contain at least 15 inches squared of pie. All right, what kind of measurement is inches squared? Inches squared, because of the squared there is an area. All right. So, what is the degree measure for the smallest sector of the 8-inch round pie that will satisfy Wendell's cravings? So, sector is leading you toward area. That's telling us area is degrees out of 360 times pi times radius squared. All right, Wendell wants 15 inches squared, so that's the area. So the 15's going here. Degrees, we don't know. That's what we're trying to find out. Degrees over 360 times pi times radius, we do know. That's 4 squared. All right. Now, to solve this, we have to solve for the degrees. I am going to go ahead and multiply both sides by 360 right now. Times 360. And if you can do this without writing it, please do so. Times by 360, so 360 times 15 is 5,400 equals, and then over here, when I do that, the 360s cancel out, and we're left with 16 pi times the number of degrees. I like to write out the whole thing, degrees there, or just DEG as opposed to just D, because D makes me think of diameter. And I'm not looking for a diameter here, I'm looking for degrees. So I always write the whole degrees. Now, to get that degrees, we're going to have to divide by 16 pi. And this is very, very important the way you do this on your calculator. That's why I hope that you are, in fact, doing this with me on your calculator. We're going to have to divide both sides by 16 pi. Degrees is 5,400 over 16 pi. Now, if you want to use a fraction bar, that's 5,400 divide, oops, don't need that divided by there. And then put the 16 pi in the bottom, and you're good to go. And that is 107. Oh, did I do this right? Yes, I did. Sorry. I was looking at my notes for another problem, and I couldn't figure out why the answer was wrong because I was looking at the wrong thing. So degrees is 107 point, oh gosh, this is going to be 430 degrees. All right, now, if you don't have the fraction bar or you don't want to use the fraction bar, that's fine. You just have to be careful that you do 5,400 divided by the whole 16 pi. You have to put it in parentheses. If you don't put it in parentheses, what that'll do is that did 5,400 divided by 16, got an answer, and then it multiplied that answer by pi. So don't do that last one. Either use the fraction bar or make sure you put that 16 pi in parentheses. There's the degrees that we're looking for. Wendell, you have to have a 107 degree angle. It's a pretty big piece of pie. More than a quarter of the piece of pie, right? Or a quarter of a whole circle. A quarter of a whole circle is 90 degrees, so that's more than a quarter. All right, now, how long should be the string to measure the outer arc of this sector? So how long, that's arc length. That's arc length. And you know arc length is degrees over 360 times 2 pi r. Okay, now, there's your degrees right up there, but it wasn't exactly 0.430. So 107.430 ... over 360 times 2 pi times radius 4. All right, now I am going back to my calculator, and I'm going to use the fraction bar here. And I want that 107.430 yada, 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 or we rounded it 429. I do not want to round it off in the middle of the problem. So I'm going to arrow back up until I get that number, hit enter, and it will transfer. Look at it, transferred all those decimals down there. Divided by 360 times, and then I can make that 8 pi. And there we go, 7.500 inches. All right. Let's take a look at this next one. What if Wendell wants to eat off of the 9-inch pie? Not the 8-inch pie, but the 9-inch pie. What's the degree measure of the smallest sector? Anytime you see the word sector, you have to be thinking area. And area, degrees out of 360 times pi times radius squared. He wants his area to be 15 degrees over 360, pi times 4.5 squared. All right, again, just like we did up above, I'm going to multiply by 360, and look, it's going to be the same thing. 15 times 360 is 5,400 equals pi times, all right, now I need 4.5 squared. That's 20.25. And now I can just take that 5,400 and divide by 20.25. Uh-oh. Oh, degrees. Lost it. I didn't have a variable there anymore. I'm going to have to divide by that 20.25 pi. So our degrees are 5,400 over 20.25 pi. 5,400 divided by 20.25. Did you notice I did parentheses there? I didn't use fraction bar, but I did enter parentheses. And I have 84.883 degrees. All right, now down here, how long should the string? How long is leading you toward arc length? Okay, so arc length is what we're looking for, and that's degrees. That's going to be that 84.883 over 360 times 2 pi times radius 4.5. I'm going to do this all on my calculator. I want this number. divided by 360 times 9 pi. 6.667 inches. Because it's arc length, inches there. All right, one last problem here. A sector in the 9-inch round pie measures n degrees. So some random number of degrees, call it n. What is its area and what is its arc length? All right, first off, area. Degrees over 360. So n over 360 times pi times that radius squared. So that's 4.5 squared. All right, now I'm going to figure out what this is without using that n. So if we think about what this is going to be, without that n in there, let's see, the pi's on the top of it, well, that becomes 1 over 360. So if I use my fraction bar, 1 over 360 times pi times 4.5 squared. Now, that is then 0.1767 times n, because I left the n out. Well, now I got to stick the n back in. 0.1767 n. There's the area. All right. How about arc length? Again, degrees over 360, n over 360 times 2 pi r, 4.5. All right, well, here's what I see first on this one, because stuff simplifies. 2 times 4.5, that's 9. So I have 9 pi n over 360. See this 9 divide out with that 360? 9 goes into 360 40 times. So right now we have pi n over 40. Or if you want to change that to a decimal, just leave the n out for a minute. And let's just do pi divided by 40, 0.0785, 0.0785, and then we'll put the n back in, n. There's the general cases. Okay, thank you very much for your attention today. I hope that you did, in fact, use the calculator along with me and that you were able to follow this. If not, please watch the video again and slow things down, pause it now and again so that you can catch up with what I did. Thank you very much. Oh, forgot. Please make sure that you work on section 7.7, ready, set, go. So we did 7, day 2, 7.7, ready, set, go. This is due Wednesday. All right, right now you can do all of this all the way up to probably the go. You should be able to get everything done, and some of you might even be able to get the go done if you want to take a look at it ahead of time. All right, now thank you very much. I'll see you tomorrow.